Hello everyone. Good evening. So basically today we need to start. The topic name is software defined network. In SDN concept we discussed SD-WAN, and before start SDN concept must be go through the traditional network. Okay. So in traditional network, which type of challenges we are facing? So must be first we need to clear the traditional network. Then we discuss the SDN concept. So before we start SDN concept, we need to discuss some small topics, you can say. So in a network, we are getting a multiple types of networking devices, or you can say network devices. Basically, first device we are getting a router, then second is switches, then third is firewalls, and fourth is access points, and fifth is a load balancers, sixth is IDS IPS devices we are getting, and seventh we are getting some sort of servers. So these devices we are using in network. IP phones we are also using, but IP phones not possible to manage by some controllers, but we can use those devices in network devices. It's a mandatory devices we are using. So before start SDN concept, uh, we need to discuss about traditional routing concept. In traditional routing concept, we discuss multiple things, but whenever we are doing a traditional routing, so we need to perform some switching tasks. In a switching task, we need to perform some access port, some trunk port, some VLAN concept, some DTP concept, VTP concept, STP, IVR, RSTP, or link aggregation, or you can say we are also performing some advanced part. We are performing some span concept. Span means a switch port analyzer. We discuss some syslog configuration. We are also doing some security features for switching. So in traditional routing, we are doing this concept whenever we are designing a network. In a network on switches, we are running some features: access port, trunk port, VLAN, DTP, VTP, STP, IVR, RSTP, MSTP. You can also add MSTP as well. So this protocol features we are running in traditional. Okay, in traditional routing, we are also performing some routing concept. In routing concept, we are performing, for example, static routing, default routing, some dynamic routing. In dynamic routing, we are using some EIGRP, OSPF, BGP, IS protocol, clear? In dynamic. Then we are running some ACL task, net task, DSCP, okay, triple PoE concept we are also performing. Then we are also performing one more task, policy based routing, VRF concept, clear? And then we are running DMVPN, MPLS technology. So this kind of technology we are using in routing part. Okay. In traditional routing, we are also performing one more concept. You can say security features. You can say security features. We are discuss port security. Port security we implement in LAN. DSCP snooping we implement. Then we discuss VLAN, ACL. Then we are running for IP source card. Then we are running ARP inspection, VLAN hopping attack. So this kind of features protocols we are running in traditional routing. Okay, every traditional routing we are using this three concepts: static, default, dynamic routing, switching in VLAN, DTP, VTP. We are almost running STP also. We are almost running security. We also implement in my traditional routing concept. But which type of challenges we are getting in traditional routing? For example, we are getting small diagram. So I'm creating some HQ. HQ means, or you can say headquarter or head office. Clear? So basically, in my head office, we are getting some sort of routers, router one, router two, and router one, router two connected with ISP, and then router one connected with some firewalls, router two also connected with some of firewalls. This kind of topology, then firewalls connected with some uh, you can say a core switches. This firewall connected also core switches. This firewall connected with core switches, and this one also connected with core switches, and core switches connected with together also. And then we connected some distribution layer switches. This side we are also getting distribution layer switches. This one. Clear? Now, then we are connecting some access layer switches, and access layer switches connected with some end devices. Some access layer switches connected with access points to provide a wireless connectivity. Some access layer switches connected with some of servers. This access layer switches connected with some database servers also. So basically, this one is my HQ. You can say headquarter or head office. This one. This one is my HQ, and this HQ available with some of servers. This one is my application server, and this one is my storage server. You can say this one is database server. So basically, this topology we are using in my head office. In this topology, we implement routing, switching, security, some firewalls, some load balancing, multiple things we are running. For example, if I want to connect with this HQ, some branches. So basically, this one is my branch. This one is branch number 1, and this branch available in Delhi location. And this one is router, and this branch connected with some ISP. Clear? So whenever this branch connected with ISP, and ISP will provide internet service, and this branch want to access my application server or database servers. So how to provide a connectivity? So in this case, network engineers first need to go to this routers and define some, you can say tunnels configurations, then implement after tunnel. Then we need to configure some on firewall, some policy to allow a Delhi branch traffic. Clear? And after policy, we need to go to core switches to configure some path or configure some rules, ACL tasks, because we are also already configure VLAN ACL. Then we need to configure some VLANs allocation about this branches to pass the traffic via this link, and this one links. Clear? Okay. After passing the traffic of VLANs, then this distribution switch is also known as if this branch. So this switch is also configure some VLAN and trunk allowed VLAN information. Then after allowed VLAN information or VLAN information, data reach on my database servers, access layer switches. So if you add a single branch, so we need to implement multiple things in my HQ, multiples. This one is my layer 3, this one is my layer 4, this one is layer 3, this one is layer 2 or layer 3 working together, this distribution switches. Now, so multiple layers, we need to configure multiple things in my traditional routing. So for example, if you want to connect it, your HQ with some branches, so we need to implement a lots of things. So basically, if you connect this branch router with ISP, so some network engineers also sitting on this HQ. This one is network engineers team, and this network engineer team must be access your a branch router first or remotely. After access remotely, this router must be configured some protocols, some routing concept, some authentication details, some login details. And after this one, this router possible to access this application server or database. Clear? Now, basically, how many ways to connect to my WAN network we discussed. But before discuss, our SDN concept must be clear. This in traditional routing, if we want to connect a single branch, we need to do a lots of configuration on my HQ, on firewall, on router, on core switches, distribution switches, access layer switches, and then a server also. If you are using a Microsoft servers and other vendor servers, so we need to provide some authentication also from my Windows server. Okay. So branches possible to connect, but a way of connecting is multiple. But providing authentication or providing the data traffic or path, so it's so difficult in traditional routing. So next step is if you want to connect a multiple branches, one to 10 branch if you want to connect it with the HQ. So we need to implement multiple protocol, multiple feature, every device, each and every nodes also. So in this case, a traditional routing will get some issues to do configuration, lots of devices. So we are moving step by step the SDN concept. Basically, in SDN concept, we follow some software defined network solution. SDN will divide it into three parts for data centers, for LAN, for WAN also. If someone asking how many way to connect my branches with my HQ in traditional routing, in a traditional routing, and why we use a WAN concept, why we use a WAN concept, and how many way to connect my WAN areas. So basically, if you are getting a WAN scenario, because right now HQ connected with branch, so we need to discuss a WAN called, it's a wide area network. So if you discuss about the wide area network, so wide area network can connected with your HQ, clear, with your branches, with your small office or home office connectivity, with your uh, you can say some city connections you can get from one city to another city. If you want to connectivity, you can also get some branches available in Delhi city, some branches available in Bangalore. So you can connect it with wide area network. But a way of connection wide area networks, we are getting a multiples way of connection of wide area network. First connectivity, we are getting MPLS technology. MPLS technology also provide to connect your branches, SOHO, HQ, cities connectivity. Second connectivity is you can get also internet, a broadband connectivity. With the help of broadband connectivity, you can get connected with your branches with HQ. Third connectivity is sometimes we are getting a triple PoE connections. If you are using a MPLS connection, if you are using a Airtel ADSL line or DSL line, so we are getting some username and password authentication to connect internet. So username and password authentication means we are using a triple PoE. Sometimes nowadays we are also using a 4G internet connection or 5G internet connection to connect my branches. Or sometimes we are using a lease line as well. So this one is way of connectivity, wide area network. So 5 methods we can use to connect my WAN networks. But if you're trying to connect it your WAN networks, so must be use this technology. If you are using a MPLS technology, you need to define lots of things. But ISP will provide ISP, Internet Service Provider will provide this way of connectivity or WAN areas. If you are connecting your WAN areas with the help of traditional routings, so we need to configure some tunneling concept, some VPN concept we are using. And then this concept we need to secure. If you want to secure your connectivity, secure your data, we are using IPsec concept to do encryption task. So this one is separate task we need to perform. But in this case, if you want to connect your HQ devices with a lots of branches, for example, 100 branches or 10 branches or 20 or 50 branches. So that means this core devices, this one, R1, R2, this firewalls, this core switches. we need to purchase high end. Why we purchase high end? Basically, for example, if you're having a networking device, if you're having a router, if you're having a firewall, if you're having a switch, so those devices basically getting some planes. How many types planes we are getting? First plane name is we are getting a control plane. Then second, we are getting a data plane concept on every device, each and every device. Then third is my management plane. So each plane separately work every device, each plane. For example, this router basically perform a routing task, security task, some net translation, some policy configure, some quality of service configure, some class of service configure on this router. So this router having some CPU, some RAM, storage also available, some interfaces, this information available every device. So every device will maintain this information separately via control plane, via data plane, via management plane. So basically, if someone asking what is the meaning of control plane is simple. Whenever devices exchange updates, update means for example, layer 2 protocols, for example, layer 3 protocols, for example, routing, for example, network. So whenever we exchange information, then control plane will work. So basically, router, firewall, switch separately maintain control plane every time. Now next, data plane means whenever users or devices forward or receive data traffic, then we are using actual traffic. If you are trying to access your Gmail account, if you're trying to send some files, if you're trying to log in with your ID with you can say some official website, if you want to log in, if you want to log in with your panels, so we are using this kind of scenarios. Now, next thing, what is the meaning of management plane? Each and every device having some CLI option to manage, some GUI option to manage. So management plane means how to manage our devices via GUI method, via CLI method. So each and every device having separate plane. In my HQ, in my core devices, that means this one device having control, data, and management. So basically multiple planes, but CDM is very important. Control, data, and management plane. Every device having control, data, management. For example, this branch sharing some network information. For example, 10 network information. Exchanging 10 network. This branch having a 10 network separately in LAN department. Some sales, some marketing, some other customer support department, multiple department available in branch. So every branch having a 10 network. If you're having 100 branches, then 10 multiplied by 100. So this router receiving multiple network information in routing table. So if you are receiving multiple routes in routing table, so this device utilize some CPU, store information, that means use some storage memory also. If you are storing some information, that means a device will process in buffer memory. Whenever branches user trying to access your database or application server, so this router will process the packet stored in cache memory and then process. So every device will maintain CDM. CDM means control data management. So in traditional routing, whenever we are deploying or designing a network, we must need to verify each device processor, RAM, storage memory, buffer memory, and interface speed. So in traditional routing, we are getting some challenges. If you're having a lots of branches, so not possible to manage. So in this case, we are using SDN concept. Basically, SDN completely software defined network. Why we use a software defined network? This software defined network will divide it into three parts. First part will maintain a data center department. If you're having some data centers, so you can manage by some controller, some devices with data center devices. In data center, we are using some Nexus series devices, some Core series devices, some high-end series devices we are using with highest CPU, 2-core CPU, 4-core CPU, 8-core CPU with 8 GB memory, 16 GB memory. So data center network we can manage, but SDN will provide a separate solution for data center. If you are having a LAN department, in LAN department we are using a core switches and distribution layer switches, access layer switches, access points, end users, printer, laptop, IP phones. This kind of devices managed by a LAN. So for LAN, software-defined network solution will provide us separately. So a LAN solution is separate. For WAN, we are using a separate solution. So if you want to discuss about the LAN solution, we discuss SD access concept. SD access. It's a separate solution for LAN. If you want to discuss about the WAN, so we discuss separate solution. It's called SD-WAN. Software defined wide area network, software defined access layer areas. Clear? Data center we can manage by some advanced devices. You can say epic controllers. This one concept we are using in data center. Right now in today's lecture, we need to only discuss about the WAN concept. So in WAN concept, we discuss only SD-WAN. Whenever we discuss SD-WAN, so always clear it's a software defined wide area network. This area, WAN area, we can manage by software defined. But software defined means we are using some controllers. So we are using some different kind of controller, and this controller why we use? So this controllers manage separately each and every planes. For example, why we use each and every plane separately managed? For example, if you're having this design, router 1 connected with a router 2, router 1 connected with a router 3, router 3 connected with a router 4, router 1 connected with a switch, and switch connected with some of LAN users, and router 4 connected with a switch, and switch connected with a servers. Clear? And router 2 connected with, for example, ISP, and router 3 connected with a switch with some users less access points. Clear? Now, in this case, what will be happen? For example, if you are running EIGRP protocol, if you are running OSPF, if you are running IS protocol, if you are running BGP. So this protocol help to do a communication in between indirectly networks. This protocol also help to exchange a network information. No need to define a destination network manually, automatically exchange. But each and every protocol, EIGRP, OSPF, ISIS, and BGP will form neighborship for reliable communication. If you want a reliable communication, those protocol will helpful. Now, in this case, for example, this server sitting on X network and this user sitting on Y network. If you form neighborship and this link is 1 GB, 1 GB, this one is 100 MB, this one is 100 MB. So if you are running any routing protocol, so automatically R1 getting a best path via R2. So whenever this user want to reach X network server, so data traffic will pass on via R2, then R4, then server side. But each and every devices separately form neighborship, separately exchange a network information together. Clear? So after exchanging neighbor informations, after exchanging update information, each and every device separately maintain RIB, FIB tables. RIB means routing information base information table. FIB means forwarding information base table. So routing information is table only maintain network information and interface information, and FIB will maintain network information interface, and how to pass the data traffic. This information is stored by FIB. So each and every device maintain RIB, FIB, and each and every device also maintain neighbor table also. Each and every device also exchange network informations. So in this case, every device utilize a CPU, memory, some interface bandwidth also. For example, this best path goes down. That condition R1 again calculate the best path to reach X network. In this case, R1 verify I'm having one more neighbor with R3. R3 verify I'm having one more neighbor with R4. So traffic will be manipulated by this one via this one person, but after going down this person, R1 will take some convergence time and manipulate the path. That condition, R3 will say, okay, I'm having a best path to reach R4 side, you can use. So R1 will change the path from a routing table. If path changed by RIB, so FIB also exchange. FIB also change. So each and every device will change. So R2 will say this path is down, but R3, R4 will again change the path information to reach X network. So in this case, each and every device, a control plane, that means update will exchange, data plane, yes, exchange, management plane only one time. Management plane is only one time because we already defined the neighbor information. But if you make only neighbor via R1 to R2, only one time neighborship will form with this person. If this neighborship goes down, so we need to perform again neighborship with this person. But in production network, we form multiple neighborship. So no need to do configuration multiple times. Only one time configuration we are doing. So if we form two neighborship with R2 or R3, if R2 goes down, so R1 again calculate the path to reach X network. So each and every device again verify control plane information, data plane information. So in this case, in traditional routing, if you want to forward 100 user, 1000, 5000 user traffic, and if link goes down, so we are getting some convergence time. Processing is slow. If you are sending some data and link goes down, so your data traffic will be dropped. The data traffic will be dropped because R1 again need to calculate the path to reach X network. So that is the reason we introduce a SDN concept. SDN concept means software defined, but right now each device separately, in this case, each device separately maintain control data manage, but in SDN concept, controller will maintain CDM table. CDM means control plane, data plane, and management separately maintained. How many types controller available in SD-WAN concept? So we need to discuss. Now go to next slide. If we discuss SD-WAN, so we are getting controller. First controller name is a vSmart. Basically, this SD-WAN solution, this solution are provided by different types of vendors. Basically, router also provided by different types of vendor. Na HP, Nokia, Juniper, Hawaii, Alcatel, multiple. Solution also provided by multiple vendors, but mostly we are using a Cisco. So basically, today we need to discuss only Viptela solution. If we discuss Viptela solution, so Viptela solution, if we discuss, so V means Viptela vSmart controller we are using. vSmart is separately maintain your control plane information. If you want to exchange any information, so vSmart is available. SD-WAN concept, one more controller introduced. It's called a vManage. vManage means virtual manager. This virtual manager will maintain your management plane information. Now, SD-WAN introduced one more controller. This controller name is a vBond. Why we use vBond? This person only do one task. This one is not related with your plane task. We discuss plane task separately. It's called orchestration plane. But right now, vBond we are using for authentication purpose right now. Authentication only. Then SD-WAN we are getting some WAN edge devices. Basically, if someone asking, so why we use managed devices? So right now, this controller will maintain any management plane task? No. So basically, this managed device will separately maintain a data plane task. This one, managed device. This one is not a controller, it's a device. That is the reason we are calling managed device. This managed devices we can get from two vendors, from Viptela, from Cisco. We are also getting multiple vendor, but right now we discuss only two vendors. Okay. Now, one more thing you need to discuss about the SD-WAN concept. In SD-WAN concept, we are getting controllers, but these controllers we can deploy on my cloud solution. If you're having AWS, if you're having Azure, if you're having a Cisco separate cloud, so you can deploy easily. If you're having some virtual machine concept means if you are using VMware Xsize, so you can deploy easily, no issue. That means this controller available in some logical form, some physical form. So if someone asking, so logical is possible to use, but physical, which type of devices we are using? If you are having a UCS server, so this UCS server capable to perform a controller task, clear? Controller task, not a managed device task, only controller task. Now, third concept means if you're having some managed devices. So managed devices we can use always physically. This managed devices we can use from Cisco, from Webtela, but controller, only one controller we can use physical. VBond. VBond is possible to use physically. Now, one more thing. If we discuss about the SD-WAN concept, so in SD-WAN concept, we need to discuss some advanced part. Some feature we discuss in SD-WAN, it's a mostly used. So a VPN segmentation task we learn. It's a new thing in you can say SD-WAN concept, VPN segmentation. We are using TLOC concept. We are using OMP concept. We are using DIA concept. DIA concept. We are doing AAR, application aware routing. This SD-WAN will provide these solutions. VPN segmentation, you can say as well a VRF concept. VRF, everyone know if you're having a router and this router connected with different types of customers. For example, this one is public sector. This one is public sector. This one is private sector. This one is home users. Clear? And this one is some organizations. So this router maintains a globally routing table. If this public sector network is X, this one is Y, this one is A, this one is B. So everyone network information only stored in my global routing table. If you want to do a separate information store, so this routing table we can divide with the help of VRF concept. So VRF will help to divide a global routing table into separate routing table. VPN segmentation as well, same. For example, this one is my branch 1, this one is my branch 2, this one is my branch 3, this one is my branch number 4. So in branch 1, we are using VPN 1, branch 2, we are using VPN number 2, branch 3, we are using a VPN number 3, branch 4, we are using a VPN number 4. So each and every branch separately VPN using. So that case, VPN 1 information will exchange with only VPN 1 members, never exchange with VPN 2. If you want to exchange, so different method we are using, but VPN segmentation is same as it is VRF. TLOC means TLOC is a method of to carry your branches information from one location to HQ, or from HQ to branches. TLOC separately we are calling a transport locator. This person will carry some sort of information from your SD-WAN fabric. So which kind of information? It's a carryable your you can say encryption information. It's carry your some IDs. It's carry your some tunnel information also carry. So this person is very important. OMP. OMP is a separate protocol. It's called over relay management protocol to carry your control plane information. Last time, if you are using a traditional routing, where is traditional routing design? This one. In traditional routing design, if devices will exchange update information, we can secure, but manually secure. We are enabling some authentication, some MD5 authentication we enable, some SHA-255 256 HMAC and algorithm we are attached to encrypt my a domain. No one is received, no one is exchanged. Unauthorized devices will exchange information. So in traditional routing, we are using manually plug in the authentication. But in SDN, we are using some OMP concept. OMP will use over relay management protocol. This protocol will help to carry your network information over your SDWAN fabric. Clear? So this protocol is using by vSmart person. DIA is a concept of direct internet accessibility. If you're having a branches, so branches, no need to go to first HQ, then HQ to ISP. Branches possible to access directly internet service without any check of firewall rules, without any check policies. You have some features to deploy in your SD-WAN fabrics, direct internet access. Some EAR, it's also available. It's called application aware routing. If you want to do some manipulation on the basis of application, for example, branch one using a Zoom application, or branch two users, this branch one user trying to use some application, but this application always use your MPLS link. So you have some features to do manipulation. You can choose the best path via which one. So application aware routing also available. Okay, one more option is available. It's called DPI. DPI means deep packet inspection. You have control plane policy CP. You have data plane policy as well. So you can deploy. But in SD-WAN separately, each and every feature separately you can deploy on your controllers, each and every features. Now, one more thing you need to discuss about the SD-WAN. For example, if someone says, sir, if I am using vSmart, so this one is controller basically. If you are using a vSmart, so this one person always use OMP protocol. OMP protocol always use to exchange your updates, create some tunnels also as well. Second thing, vSmart only work on your routing information, some policy informations. Third thing, sometimes network engineer get this person name. This one is most popular person, cluster. Everyone getting sometimes confusion. What is the meaning of cluster? Cluster means we are doing a bundling. If we are getting a 2V smart, if someone goes down, so we are getting a backup person. Clear? So cluster concept also support your SD-WAN solution. So cluster, if you want to do, so we can get fourth option in vSmart. Fourth option must be verify your device information. Device information means if you want to connect your some sort of branches, for example 10 branch, 20 branch, 50 branch, 100 branch, 250 branch, or 500 branches, if you want to connect with your vSmart, must be verified device, CPU, RAM, storage, or interface capability must be verified. This capability will define how to do this person work. If you're having a lowest configuration, so this person is not capable to do a quick response. Clear? So always verify. One more thing you need to discuss about the fifth point about a vSmart. vSmart is a person to propagate. Propagate means a forward or inform all branches. So propagate a policy informations. If you deploy some policy, some manipulation tasks, some load balancing tasks, some uh, some policy for about application aware routing, some DIA, some net concept. So this person is only propagate vSmart. Same kind of vManage also available. This side we can write down vManagement. So this person basically also act as a controller, but this person centralize manage each and every controller, plus you can access your manage plus your firewalls. Centralize. One more thing you can do, this person will help to do a troubleshooting. This person also do to help to do a monitoring task. If you want to do a one more task, mostly network engineer do this task. If you want to do any upgrade task, if you want to do any backup task, if you want to do any other task, deployment task, so you can easily do via with one person, vManagement person. This one person available in GUI option. vSmart only available in my CLI option. Okay, you can configure protocols, you can deploy some policy. If you want to do some changes, name, license, all information you can do via vManagement. But why we use vBond? Why we use a vBond concept? So vBond is a very important controller. Basically, this controller we can make if you are having a router which supported some SDWAN operating systems. So we can convert router as a vBond device. But this person only work on my authentication. This person authenticate managed devices. Authenticate managed devices. Basically, this vBond having some list option, or you can say this one is whitelist. This one person called whitelist. If you're having a whitelist, this whitelist will carry your license information, chassis number, serial number, clear a token number, some information available in this whitelist, and this whitelist uploaded on vManager. vManager will exchange with my controllers. So vBond will verify a connected branch when his device is authenticated device or unauthenticated device. If you are getting a valid device, so easily exchange information. This one is first option to do, connect your branches. Second option is you are getting some a ZTP concept. ZTP. This person is also available. It's called zero touch provisioning. No need to access your branches router and do lots of configuration. Only provide connectivity with internet, and then from one place to configure all configuration your branches. So ZTP also you can do zero touch provisioning. And third option is PNP. PNP we are also using in real time. If someone is working as a SD-WAN engineer, so almost 90% students know why we use PNP concept. Basically, this one is plug and play concept. You need to connect your devices with internet service, and then you can easily access. So PNP service we are using. Fourth option is Cisco smart accounts. If you're having a Cisco smart account, no need to connect with your vBonds. You can easily validate your managed devices for branches. You can easily access. Now, vBond basically provide controller information. If you get a validated license, chassis number, serial number, then vBond will provide a controller information. One more thing, always available publicly. This person always available publicly. This person, if connected with private IP, you need to perform the net task. But this person always available publicly. Publicly, you can access this person via two methods, with IP, with your FQDN. If someone getting confusion with FQDN, FQDN means fully qualified domain name. For example, webtela.jntech.com. This kind of name you need to provide a publicly accessible. So if this vBond is publicly accessible, you can easily get the controller information and your branches easily get up and easily receive the information, your HQ database server or application server information. Now next thing is how many topics we cover in SD-WAN solution. So if you're learning SD-WAN solution, complete training. So I think it will take 1.5 months or one and a half month, you can say. We provide uh, total 4 labs. 3 lab we discuss in your lecture. Fourth number lab you need to do a self. Then third thing, the study material you can easily get some PDF format, some notes, some data sheets about the controllers, about the managed devices, which device will be provided for 100 users network, which device we need to use about if you are having a 1000 users, if you are having only 10 sites, so which controller we need to use, which configuration we required, if you are having only 2 sites, so how many processor, how many CPU required on my controllers, how many managed device, and which type of managed device required. So this kind of information we discuss in data sheet also. Then fifth option is basically if you want to do a lab, so you can get easily lab access in your training session. If you are doing a training, so in between training you can easily get the lab access. So we are if you're planning for SD-WAN lab, so we are also having some servers. SD-WAN solution, if you want to learn, so must be CPU required. I think 64 core CPU must be required, and RAM minimum 256 GB RAM. It's almost required. And storage, you can say 500 GB, but this one is SSD required. So this one is, I think, total lab in SD-WAN, 40 to 45 labs available. So you can easily go through the website and you can get information about how many lab session, how many theory session available. So you just need to how to know the information. You just need to go to networking training tab and go to Cisco SD-WAN. Click on this one. Some videos also already available, this one old session videos, and must be before start the SD-WAN solution, must be understanding the WAN technology, routing, switching, and some basic security, not a complete firewall training, only basic, why we use and which scenarios, and how data traffic will be passed via only this thing you need to get before doing SD-WAN. And then how many modules available in SD-WAN? Basically 1, 2, 3, 4, 5, 6. 6 module available in SD-WAN. And this one is labs during in your training. We discuss. This one is lab part 1, 2, 3, 4, 5, 6, 7, 8. And I think total is 12 to 14 modules we cover in SD-WAN training. So first lecture we discuss about this topics. What is the meaning of T-log, IPsec, vRoute? vRoute means a virtual routes, and BFD, bidirectional forwarding decision, why we use, which type of managed devices, and which scenarios we are using, which kind of serial number managed devices. And then we discuss next a deployment is very important if you discuss in real time. So mostly network engineer getting some confusion, how many RAM, how many CPU, and which type of interfaces we need to require for controllers. So we discuss each and every points in deployment section. Then we discuss about the managed device deployment, how to connect your branches with HQ via when methods, MPLS, lease line, triple PoE connection, some under relay protocol we discuss. Mostly person are getting confusion. What is the meaning of under relay protocols and what is the meaning of over relay protocols? Basically, if you've done your CCNA or CCNP part, so you just clear IGP protocol and EGP protocol. So basically, IGP protocols mostly we are using, you can say, under relay protocol. IGP protocols under relay. If you are using EGP protocol, so this protocol we can use over relay in traditional routing. In traditional routing, we are using over relay, but in traditional routing, this over relay protocol convert into my under relay protocol because some sort of managed devices not using EIGRP. Some devices support, some managed devices not support EIGRP protocol. So always clear. Under relay or over relay protocol is very important. Then in our deployment case, we discuss how to form T-log tunnels and which scenarios OMP will establish, how to troubleshoot, how to verify. Clear. So this kind of under relay concept we need to check. Over relay concept we need to check. Okay. How to configure the VRRP, OSPF, BGP. Clear. I think this one is also available. ZTP, zero touch provisioning and plug and play concept. We already done this one topic. Discussion only. Then we discuss policies. Okay, policy we discuss control data, VPN segmentation or end-to-end segmentation we discuss. How many types topology we design, and then we discuss application aware routing, direct internet access, deep packet inspection, or data prioritization topic we also discuss. In quality of service, we discuss data prioritization, queuing, shaping, policing. If you're already working as a network engineer, you already know if you're having a router, if you're having a core device. So basically, we need to define how many CPU utilized for videos, how many CPU utilized for data, actual data, how many CPU utilized for my, you can say, other traffic. Some policy for policy based routing, how much traffic will carry via another percentage. So percentage based we need to define queuing and shipping. So this topic we need to discuss. If you deploy SD-WAN solution in real time, so must be configure the quality of service, must be. And then we discuss management and operation part. In management and operation part, we discuss what is the meaning of REST API. Okay, everyone, I think I already know the automation concept. Automation. We need to do a scripting part, but right now in SD-WAN course, we are not discuss scripting part, but we discuss, I think small scripting part, we can run 1 to 5 script we are running to do some automate. Clear, we controllers or managed devices. 1 to 5 script we can run. Then we discuss about our next concept. This one is lab sessions. How many labs we discuss, so you can verify. This one we manage, we smart, we want, and we also discuss routes here. Okay, in production network, mostly production network using some enterprise CA servers, and mostly organization use a Cisco smart account, and mostly organization use a ZTP concept, not STP, this is CNFR, ZTP. So these three concepts we discuss, but Cisco smart account must be having. Yeah. So we discuss CA server, how to create a CA. Basically, this CA server name is ADCS, Active Directory Certificate Server. Yeah. How to provide a locally certificate, how to activate your controllers. No need to connect, no need to having a organization account. You just need to only attach your Windows server. You can easily activate your controllers. PKI concept also available, but PKI is an old method. Right now it's a very complicated. You need to sign, self-sign, then certificate sign, then multiple things, lots of things we need to do. So enterprise CA server, it's a easy method, so you can easily do. But in mostly 95% organization will use a Cisco smart. If you're using a WebTailor solution, so Cisco smart account already used. So this smart account will have having license information, some chassis number information, some one-time password. You can say OTP, or you can say token information also available. Token information. Now one more thing. Policy we can configure. I think total lab is 41, but this one is only showing 41, but I will provide, you can get 45 labs, 4 lab extra you can get from me. 4 lab we discuss real-time scenarios. Real-time scenario means some tickets we can resolve, some tickets. if you're trying to deploy, if you're trying to troubleshoot, and you can say how to troubleshoot our running networks. Yeah, if you are getting in SDN solution any issue, so how to troubleshoot. Four labs we discuss, and this one is server. This one, this kind of labs we can use multiple labs. This one is a fourth number lab, and you can use, I think, five labs available. One, two, three, four. This four labs we discussed. One, two, three. This one is third lab. This one is fourth lab. We discuss multiple. We discuss both managed devices, Cisco plus Viptela. How to, but right now each and every lab we are doing on EVNG. You can easily do on JNS3. You can easily do on VMware also. If you're having a VMware access, you easily do. But EVNG is a better uh, simulator to do a labs. You can drag and drop. You can easily capture your data traffic whenever traffic pass via controllers, whenever traffic pass via managed devices. So you can easily do. So this one is a lab part. If you want to do a lab, so I will provide some credential, and this server you can easily access. Basically, this server having some uh, RAM, CPU required. That is the reason. Or if you want to check one more thing, so this one this one is my profile. You can verify. So we can start the SDN part. Okay. As in SDN, we discuss only SD-WAN solution. Only SD-WAN solution. LAN part is a SD access. LAN part is SD access, and data center part is APIC controller. Right now we discuss only Viptela solution. So you can click on Cisco SD-WAN training tab, and then you can easily redirect on SD-WAN section. So you can easily verify each and every topics lab part, this one lab parts, or you can easily download. Okay, so we meet again next week and discuss some advanced topic in SD-WAN deployment part. We can also discuss.